Alright, congruence in triangles. Basically, two triangles are congruent when the corresponding sides and corresponding angles are congruent. So taking a look at these, we can see which ones are corresponding. A is going to go with X, B is going to go with Y, and C is going to go with Z. Now they're not always perfectly lined up like this, and sometimes they're even touching, but what you're looking for is corresponding parts or parts that look the same. Triangles have 6 parts. They have 3 angles and they have 3 sides. So this means that you can write 6 congruent statements for every set of congruent triangles. So for the above triangles, which you'll see right there, you're looking at angles A is congruent to angle X, B is congruent to angle Y, angle C is congruent to angle Z. In addition to that, you've got side AB is congruent to side XY. Side BC is congruent to YZ, and side AC is congruent to XZ. So all the corresponding parts are congruent to each other. Now, in addition to the small congruent statements for each part, you can write a congruent statement for the entire triangle. So the trick to this is that the corresponding parts have to be kept in the same order for the congruent statement. So when you write triangle ABC, it's congruent to, triangle XYZ. If A goes with X, they have to be in the same spot in the name of the triangle. So A goes with X, you'll know that B goes with Y, and C goes with Z without even having to see the triangles together. Also, you can see that segment AB, if you look right here, segment AB goes with XY, segment BC with YZ, segment AC on the outside edge goes with XZ. Now there's not a wrong or right way to start how you put the order for this one. So if you wrote triangle BCA, that's totally fine as long as you change around the order of the second one to YZX. So corresponding parts have to be in the same order when you write this. That way someone reading this statement doesn't have to have a picture of the triangle in order to know what angles and what sides are corresponding to each other. So if all the corresponding parts of the triangles have to be congruent, there's a quick way to write congruent parts of congruent triangles are congruent. Cpctc. Okay, that's the abbreviation for congruent parts of congruent triangles are congruent. Alright, so how would we use a problem like this? So we got to show that the following triangles are congruent and write the statement. So we're given this picture here where we see that all the sides are congruent, but we're only given one angle. So what we do is we're going to take a look, and because angle EBA, now if we look at this, EBA is this angle right here, and angle CBD is this angle right here. You've got to be specific when you have one letter that could be assigned to two different angles. It says we know that they're congruent. That is because they're vertical angles. Vertical angles are vertical angles even when you're not talking about parallel lines and transversals. They're always vertical to each other. Alright? So because I know that those two are congruent, and I know that the A and D are congruent to each other, that leaves you with the fact that E and C must be congruent to each other. So all 3 sets of angles are congruent, all the sides are congruent to each other, so all the corresponding parts are congruent. So the congruent parts of congruent triangles are congruent. And I realized I just made a mistake. After all that, corresponding should be this word right here. Corresponding parts of congruent triangles are congruent. That makes so much more sense. Corresponding parts of congruent triangles are congruent. So, I make mistakes even on videos, and I'm not even going to record over it. Alright, so corresponding parts of congruent triangles are congruent. So, all the corresponding parts, A and D, E and C, B and B, the segments are all congruent to each other. We have 6 sets. So our congruent statement for the corresponding parts is triangle ABE is congruent to triangle DBC. Thank you.